This lesson is for Geometry, Chapter 11, homework number 10 on surface area and volume of spheres. So a sphere is the set of all points in space equidistant from a given point called the center. And you're familiar with a sphere because it's the shape of a ball. So here is the model of a sphere. And this particular model is split into two hemispheres so that they don't roll around in the classroom. But anyway, the only dimension of a sphere that's important for finding the surface area and volume is the radius. And the formulas are 4/3 pi r cubed and 4 pi r squared. So this problem is asking you to find the surface area. And the surface area is 4 pi r squared. So it's 4 pi, and the radius is 8 squared. So it is 4 pi times 64, and 4 times 64 is 256 pi. And it would be inches squared for surface area. Because remember, the surface area would be like if you were trying to wrap this ball in a piece of wrapping paper, and it's the wrapping paper we're talking about. So it's the number of square inches it would take to cover the surface of the sphere is 256 pi inches squared. And you could get a decimal for that. So if you did 256 times pi, you could write down this decimal, but in math we generally just try to we just leave the pi in there most of the time because it's kind of a nicer, succinct way of writing the number than to decide where to round it off to. But basically it's saying if this is 8 inches, then there are about 800 square inches that wrap around the ball. 8 inches would be a pretty large ball, bigger than a basketball, because it's just from the center to the edge, that's 8 inches. All right, so the next one we're finding the volume. So if we're finding the volume of a sphere, it's just a matter of picking the right formula. Notice that for the sphere it's cubed, and for the surface area it's squared, because if we're finding the number of cubes that fit inside the ball, then it's 4/3 pi 3 cubed. And if you didn't get to use a calculator, rather than doing 3 cubed, you could write out 3 times 3 times 3. And then the 4 and the pi are in the numerator of the fraction, and then there's a 3 from the 4/3 in the denominator. And then conveniently, those 3's cancel out. And so your answer then is 4 times 3, which is 12, times 3, which is 36, times pi, and it will be inches cubed. If you wanted to do the whole work on a calculator, you could do 3 cubed times 4 divided by 3 and get to your 36. So if you like that better, that's fine, but I would encourage you to try to do some without the calculator. All right, so find the diameter of a sphere if its surface area is 81 pi square inches. So if its surface area, so that tells you which formula to pick. The surface area is 4 pi r squared, and I know that the 4 pi r squared is 81 pi. So then to get to solve this, I'm going to divide both sides by 4 pi, so this will become 81 pi over 4 pi. The pi's cancel, and I get 81 over 4, which I could get a decimal for that, but it's standing out to me. I like the 81/4 as a fraction because I'm going to square root to get my answer, and if I square root 81/4, then the square root of 81 is 9, and the square root of 4 is 2. So the radius is 9/2, And if this is 9/2 from here to here, then if I double 9/2, I just get 9/2 times 2, which would be 9. 18/2 or 9. So if you wanted to do that on a calculator, say you got to this far and you crossed out the pi's and then you did 81 divided by 4, you get 20.25, and then you would want to take the square root of that value and you'd get 4.5 for the radius. So that would be fine if you wrote this as 4.5, and it's inches. And then for the diameter, it would also be 9 inches. Double 4.5 is just 9. All right, so finding the volume of this cone with a hemisphere on top, I need to find the volume of this plus the volume of this. So it's not look like a hemisphere very well, but the formula for the volume of a whole sphere is 4/3 pi r cubed, but I only want half of 4/3 pi r cubed plus the whole cone. And remember that the formula for the cone is 1/3 pi r squared h. Looking for my formula sheet. You should definitely print out the formula sheet so that you have those to look at when you are doing this work. So here's the cone, 1/3 pi r squared h, and here's the sphere, 4/3 pi r cubed. If you don't know where to get that formula sheet, email your teacher and we can get you one. So 4/3 pi r cubed for the sphere, half of that, plus 1/3 pi r squared h for the cone. So 1/2 times 4/3, half of 4/3 is 2/3. And then pi times the radius, which is 1 cubed, plus 1/3 pi, the radius of the cone is also 1, and the height of the cone is 5. So 2/3 pi, or 2 pi over 3, I could say, for the half sphere or the hemisphere. And 1 squared is 1 times 5, and so I get 5 pi over 3, which is convenient that they're both over 3, so then my final answer is 7 pi over 3 meters cubed. All right, and the next one is to find the surface area of a hemisphere. This one I think is a little bit tricky, and we'll definitely look at the model of it, but let's think about the surface area of a hemisphere. We've got the part that's kind of the dome, but then we also have another surface that's kind of, if you just cut a ball in half, you would just have like an empty fishbowl. But when you find the surface area of a hemisphere, you assume that it's a closed figure and that it's not just a salad bowl with no lid on it, it's the bowl plus the lid. So you end up having to do 2 different surfaces when you find the volume or the surface area of a hemisphere. So we need half of the dome, not the whole dome, all the way around the whole ball, but then we also need to add the circle that's the lid to the salad bowl, if you will. So then the whole circle sphere, the outside of it would be 4 pi r squared. So we need half of 4 pi r squared. And then we need the area of the circle, which is pi r squared. So this ends up being 2 pi r squared plus pi r squared. Technically, you could add those together, but you might feel more comfortable finding the surface area of the dome and then the surface area of the circle. One thing to watch out for on this problem and others is to make sure that you are given the radius. And if you're not, then just make a note of it, because this 12 is representing the diameter, and so then I know that the radius is 6. So when I substitute in here, I get 2 pi times 6 squared plus pi times 6 squared. 36 times 2 is 72 pi plus 36 pi ends up being 108 pi. All right, last one, we're going to find the volume of this solid, and it's trying to be a cylinder with a dome kind of taken out of it. Like picture a tub of Dreyer's ice cream in that round cylinder container, and then you scoop out this exact hemisphere out of the top of it. So it's a subtraction problem. Finding the surface area is going to be a challenge problem, but finding the volume is a required problem. We're going to find the volume of a cylinder from a couple classes ago, and then subtract the volume of a hemisphere. That's kind of on its upside down hemisphere there. Oof, another bad drawing. All right, so the volume of a cylinder is just the area of the base, pi r squared, times the height. And you could get that from the formula sheet if you had it. Cylinder, volume, area of the base times the height, or pi r squared h. And then for the hemisphere, it will be half of 4/3 pi r cubed. Or you could just write down 2/3 pi r cubed, because you know that your half of 4/3 is 2/3. So I'm going to start substituting in here. The radius of the cylinder is 6. The height of the cylinder is 9. The half times 4/3 is 2/3. And the radius is 6. This, you can assume that that sphere or hemisphere has a radius of 6 also. And we need to cube it. So that's 54 pi minus, you could do 6 to the 3rd power times 2, then divide by 3, would probably be a good strategy on that. So 6 to the 3rd, or just 6 times 6 times 6, times 2, up. 6 to the 3rd times 2, divided by 3. 144. And what did I do wrong here? Oh, what I did wrong. 6 squared times 9. So this 54 pi wasn't right. 6 squared is 36 times 9 is 324 pi minus 144 pi, which is 324 minus 144, 180 pi. Inches cubed. All right, so I'm going to stop there, and if you wanted to try to find the surface area, that will be a little bit tricky. I got 216 pi inches squared for the surface area when I did that problem. I hope that's right. I had a mistake initially on this one, but it looks like I didn't make the same mistake on this one. So thanks for watching and good luck.